Woo! You made it! We made it to this fun and exciting part of chemistry that you're going to love or love to hate. Because it'll be either or. It's called stoichiometry. Doesn't that just sound cool? Stoichiometry. It's like, that's so stoic, dude. Like, forget the swag thing. Let's make it stoic. Like, you know, somebody looks all, you know, all cool, strutting down the hallway, be like, hey, dude, you look so stoic. Instead of swag. What do you think? I don't know. Anyways, let's take a look at these notes. All right, our first question in these notes is, well, what is this stoichiometry thing? All right, so if you open a textbook, it would say, problems involving conversions between masses and moles of reactants and products. All right, well, what does that mean? Basically, stoichiometry is math, okay, that helps us determine how much reactant we need or how much product is made in a chemical reaction. So this here is our reaction. Do you recognize it? From the Alka-Seltzer lab. That fun lab. All right, so HCl plus sodium bicarbonate is going to react to form sodium chloride, carbon dioxide, and water. So if you run up to me and say, Miss Creo, I have 100 mils of HCl. How much Alka-Seltzer should I add to get my most bang for my buck? I'll tell you, you can figure it out with stoichiometry. Yay! Okay, so that's basically what we can do with it. If you know you have this much of reactant and you want to figure out how much to get, the best reaction out of it, you'll be able to calculate how much of the other reactant to add. Or you can be like, well, I want to produce this much carbon dioxide, like a bazillion moles of carbon dioxide. How much hydrochloric acid and how much Alka-Seltzer do I need to use? Well, with good old stoichiometry, you can figure it out. Okay? All right, let's see how this works. We're going to start out with a few key or important facts to keep in mind when you're doing this stoichiometry stuff. All right, here they are. The key couple things you need to keep in mind when you're doing stoichiometry. Of course, there'll be more as we get more complicated, but this is what you keep in mind now. You always need to start with a balanced chemical reaction. So please get in the habit of always checking to make sure that the reaction that you're given is balanced. Because if it's not, your entire calculations will be wrong. So get in the habit of always checking whether it's balanced. Number 2, remember from last notes, hopefully it's been ingrained in your head by now, that the coefficients in a balanced chemical reaction tell you the mole ratio between those reactants and the products. So that means that we can use them to predict how much product we can make from a given amount of reactant. And we can also use them to predict how much reactant we need to use to get a certain amount of product. That's what I was saying before. Okay? So let's just do one little quick review of mole ratios. So if we have this chemical equation down here, nitrogen gas and hydrogen gas making ammonia, what is the mole ratio between nitrogen and hydrogen? Well, we take a look at our coefficients. Nitrogen has a coefficient of 1, and hydrogen has a coefficient of 3. So it's a 1-to-3 ratio. So for every 1 mole of nitrogen we use, we need to have 3 moles of hydrogen to make the reaction work. Okay? So that's how those mole ratios work. All right, so let's voyage into our first set of stoichiometry problems, which is what we call mole-to-mole problems. All right, so to solve what we call mole-to-mole problems, we have to know what mole-to-mole means. Okay, so here's mole-to-mole. Mole-to-mole begins with, you guessed it, moles of one substance. So in the question, you're given moles of one substance in the reaction. and you're asked to find the moles of a different substance in the chemical reaction. So here's an example. How many moles of CO2 are made when we have 10 moles of C3H8 to begin with, or when 10 moles of C3H8 are burned? Now here's our chemical reaction. Every time that you're given a stoichiometry problem, you are usually given a reaction, or you need to write out the reaction. Okay, lucky for you, I gave this one to you. All right, so let's go through the steps. There's only 2 steps to solving this. So let's take a look at those steps. All right, here they are. Step number 1, balance the equation. Okay, stop the video, balance the equation, and then move forward. All right, that's what you should have got. Okay, equation balanced, check. Number 2, set up one bridge from moles of your given substance. Okay, so that's what you're given in the question. Okay, so moles of your given substance. So in the question, we're given what's highlighted in yellow there, 10 moles of C3H8. So we're going to have a bridge going from moles of C3H8, right, to moles of your unknown substance. That's what it's asked for, okay? That's what's asked for in your question, okay? So in this particular question, it's moles of CO2, all right? So we're going to have one bridge going from moles of C3H8 to moles of CO2. So let's take a look and see how this works. All right, so here's our one bridge. We're going to go from moles of C3H8, because that's what we're given. In fact, we're given 10.0 moles of it. And we're asked to figure out how many moles of CO2 are going to be made. So that's on the right side of our bridge. Moles of CO2. So just like in all other bridges, we need to cancel those moles of C3H8. Okay, so we're going to put that down here on the bottom right-hand side. Okay, so now we have our units labeled. Now we can start putting in numbers. So we have to figure out what goes right here. What are the numbers that go on the top and bottom? Now, if we look at our units, it's a mole-to-mole ratio. That's exactly what we've been talking about all this time. Mole-to-mole ratios. Okay, so here is our mole ratio from the chemical reaction. Okay, that's exactly what we're going to put in there. So we're going to put in, how many moles do we have in our chemical reaction of CO2? Well, there it is, 3. So 3 goes on top. How many moles does it say for C3H8? 1. 1 goes on the bottom. Bam, you got it. Mole ratio from our chemical reaction. So now all we need to do is our math, right? So we multiply what's on top, divide by what's on the bottom, and what are we going to get? 10.0 times 3, guessed it, 30.0 moles of CO2. So what that means is that if we have 10 moles of C3H8 that we start with, we will make 30 moles of carbon dioxide in the end. Okay, and we know that because of these mole ratios. We can even look at the equation and say it's a 1-to-3 ratio. So if we have 10, we're going to have 3 times as much, which is 30. Okay, so that's how it works. Now let's take a look at 2 more examples. All right, here's our next example. Here's a question. How many moles of chlorine are needed to produce 60 moles of sodium chloride? Dun, dun, dun. Okay, so there's our reaction. First step, balance it. Pause and balance, people. Okay, that's what you should have gotten. Beautiful. Second step, make our one bridge. Bam. Now remember, we're going to go from moles of what we are given. So here we go. Moles of NaCl. Okay, so that's what we're going to put on our top left side. So 60.0.0 moles NaCl. And on the other side, we are going to put what we need to know or what we need to find out. And that here is moles of Cl2. So those go right there on the right-hand side. Now, once again, we need to cancel those units. So we're going to put moles of NaCl here. And there we go. So now we just need to do the mole ratio right here. Awesome. So remember, we get that from our chemical reaction. So what is the number of moles of Cl2 in this reaction? Well, Miss Creel, it's 1. You're right. What is the number of moles of NaCl in this balanced reaction? It's 2. So the 2 goes down there. Okay. Now we just have to do the math. Multiply on top, divide by the bottom. 60 times 1, 60. Okay, so 60 divided by 2 is 30. Okay, so we have 30.0 moles of Cl2. So that means if we wanted to make 60.0 moles of sodium chloride, we would need 30 moles of chlorine in order to do so. Bam. Stoichiometry at its easiest. It does get harder. All right, let's take a look at last example for these notes. All right, here we go. Last question of these notes. Last example. How many moles of hydrogen are needed to fully react with 5 moles of oxygen to make water? Now this time, I don't give you the reaction, but you could totally figure it out, or you should be able to totally figure it out. So please pause, write down the balanced chemical reaction, then push play. All right, so that's what you should have gotten. So first step, make sure the equation is balanced. We got 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. Looks balanced to me. Let's move on to step 2. Step 2 says to make one bridge. There we go. Going from moles of the known substance, moles of what we're given in our question. 5 moles of O2. Okay. So that's what we put here. 5.0 moles of O2. So we know we have 5 moles of oxygen. We need to figure out how many moles of H2 we're going to need in order to make water. Okay, so that's the unit that we're going to put over here on the right. Moles of H2. That's our unknown. That's what we're asked for in the question. Okay. Now let's complete this unit, the units here. So we have to put the moles of O2 down here so they can cancel. And now, mole ratio time. Okay, if we look here, we need to figure out conversions factor, a mole ratio between hydrogen and oxygen. So where do we look for mole ratios? Yep, in the chemical reaction. So what's the coefficient for H2? It's 2. So we put 2 here. What is the, all right, so how many moles of O2 do we have in our chemical reaction? Bam, right there, 1. So we put a 1 there. Okay, so what we're going to do now is our math. Multiply on top. 5 times 2 is 10. 10 divided by 1 is 10. Okay, so 10 moles of H2. So that's how many moles we would need to fully react with 5 moles of oxygen in order to make water. Awesome. Okay, do you get it? I hope so. If you don't, go back and re-watch some of this stuff. Tomorrow we're going to have lots of practice problems with it, but hopefully it should make sense. All right, we'll see you tomorrow.